Welcome you all for the thermodynamic class. In this class, we are going to discuss about the steam nozzles. Steam nozzles are the components which are fitted before the turbines in the steam power plants to increase the velocity of the steam from the negligible level to the significant level. And also, generally, nozzles are defined as actually nozzles are defined as these are the varying cross section components. The nozzles are defined as the varying cross section components. And if you see the cylinders, in the cylinder, the cross section of the cylinder will be constant, so that it is said to be a cylinder. If at a course, the base of the base table of the course in the if one end will be different and the point will be like a point that is said to be a core. Now when you come for the nozzles are the very cross section area. If the part of the starting part of the nozzle is high, gradually it will be converged, or the starting part of the nozzle is low, it will gradually diverge. So the cross section of the nozzle will not be a constant from one point to another point. This is the definition of the nozzle. And these nozzles are having the many applications. We are using the nozzles for the aircrafts, like there we are using nozzle to for the enhance the velocities of the gases when they are existing from the turbine. When their velocities are enhanced by the nozzle, we can increase the speed of the flight, and that is the main application we have. And also we are using the nozzles in the hydraulic turbines in order to increase the velocity of the water to strike properly on the plates of the turbine. And also we are using the nozzles in the steam power plants in order to increase the velocity of the steam. When the steam is coming out of the boiler and when it is going into the turbine and general fans, steam is having the very high pressure and very low velocity. The initial velocity of the steam when it is coming out of the boiler will be negligible when the final velocity of the steam is having after coming out of the nozzle. The main use of the velocity of the steam will be velocity is nothing but the kinetic energy. The kinetic energy is a entity which is rotating the turbine. For example, when you supplying the steam into the turbines, with help of the kinetic energy of the steam only, turbines will run. So that we have to ensure that before we are supplying the steam into the turbine, the steam should have proper kinetic energy. So that if you take the thermodynamical analysis of a steam when it is coming out of the boiler, it is having the large amount of heat and it is having the highest enthalpies when it is coming out of the boiler, and also it is having the highest pressure like some 170 bars and 180 bars. Sometimes it is also having the 220 to 200 bars also. But with help of the pressure, we don't have anything to do in the expansion of turbine. When the steam is expanding in the turbine, there is no use of pressure. When it is expanding in the turbine, the kinetic energy will play the major role there. So that before going into the turbines only, we need to convert the pressure of the steam into the kinetic energy of the steam or velocity of the steam. So in order to convert the pressure of the steam into kinetic energy or velocity of the steam, uh, the nozzles are used to do this particular to uh, take out this particular task. The nozzles are used to increase the velocity of the steam from negligible to significant level. And before going to see the functioning of the nozzle, we like to discuss about. I would like to discuss about the types of the nozzle. There are three types of nozzles exist mainly in the technical set. The main three types of the nozzles are convergent nozzle, divergent nozzle, and convergent divergent. And in this slide, we are getting the three images of the nozzles. The figure one shows the convergent nozzle. In the convergent nozzle, what is happening? The entrance of the nozzle is having the higher cross section, that means higher diameter. When it is going to the exit part, gradually the diameter of the nozzle is increasing slowly. It is slowly. So the you can see the shape of the nozzle from starting point to ending point in converging manner. Converging manner, it is going to contra. It is going to reduce from entrance side to exit side. So this is a convergent nozzle. This is a convergent nozzle. And in the figure two, it is giving the in the figure two, it is giving the shape of the diverging nozzle. Now the entrance of the divergent nozzle is less when it is compared to the exit. So that it means from the entrance to exit, the diameter of the diverging nozzle is increasing. The cross section of the diverging nozzle from the entrance to exit it is gradually increasing. So that it is called to be a diverging nozzle. Diverging nozzles sometimes we are using them as a diffusers in the jet engines. Diffusers mean this diffuser is a component which is used to convert the kinetic energies into the pressure energies. When in the case of the jet engines, for the combustion of the fuel in the jet engines, it requires lot amount of pressure. So that amount of pressure will not be produced always by the external components like compressors and axial compressors or centrifugal compressors, whatever the compressors. Why? Because in the case of the pulse jet, in the case of the jet engines, the weight is a very important thing. So, as much as possible, we have to reduce the weight of the flying objects so that sometimes some of the designs of the missiles and some of the designs of the jet engines are using the diffusers like divergent diffusers. Diffusers are same like a divergent nozzle. The entrance of the diffuser will be less and the exit of the diffuser will be high. So when we are using this particular design, it will convert the velocity of the air into the pressure energy. This is also called as a ramp. This is one of the application of the divergent nozzle. In the figure third, after the divergent nozzle, you can see the convergent divergent nozzle in the third figure. In the third figure, it is showing it is a combination of a convergent nozzle and a divergent nozzle. And the origin at which these two diverging and converging nozzles are getting in contact is called as a throat. It is called as a throat. So the converging diverging nozzle is a combination of convergent and divergent nozzle, and both will be combined by the area called throat. The throat is what? It is a constant diameter and a particular distance. Now here, if you see the convergent divergent nozzle, in the entrance, the diameter of the nozzle will be high, and then slowly it will gradually reduces up to throat area. From the throat area, again that particular diameter of the nostril, cross section of the nozzle, again slowly, gradually increase up to the exit. This is the convergent divergent nozzle. These are the main three types of the nozzles. But among the three types, in the major industry applications, in the steam turbines, we are using the convergent divergent nozzle only. So that I would very much interested to discuss about the convergent divergent nozzle. Now, steam turbines are using the convergent divergent nozzle. Now, if you want to get the thermodynamical analysis of the converging diverging nozzle, here at the entrance we are supplying the steam with the highest enthalpy and highest pressure and negligible velocity. At the entry of the nozzle, the steam will be supplied with the highest pressure and highest enthalpy with the negligible velocity. When it's going through the nozzle, some amount of the heat will be converted into the kinetic energy, and the pressure of the steam will be converted into kinetic energy. So while it is passing through the nozzle, some amount of the heat and the pressure of the steam will be converted into kinetic energy, and we are in the when it is expanding in steam, it will expand like isentropic manner, and also when it's going through the nozzle, there is no addition of heat and there is no removal of heat. That means what? There is no rejection of heat and there is no addition of heat. When there is no addition of heat and when there is no rejection of heat, it's said to be adiabatic process. On intern, it's said to be a, or else it's said to be a reversible isentropic process. By this thermodynamic analysis, we came to know that the expansion of the nozzle is isentropic. Expansion of the nozzle is isentropic manner. There is no heat loss and heat gain. Only we are converting some amount of heat into the kinetic energy. According to the first law of thermodynamics, steady flow energy equation, just we enthalpy is converting into the kinetic energy. Kinetic energy. And if you compare the sum of the energies in the entrance and to sum of the energies at exit will be equal according to the first law of thermodynamics. This is the thermodynamic analysis of a convergent divergent nozzle, and this is happening in a steam nozzle. Steam nozzles are used to increase the velocities and decrease the pressures. This is the working of a steam nozzle. Thank you for visiting this class. I am going to conclude this class.